Hi, this is Carla Brigandi, and today we're going to be doing Lesson 3 in Course D, which is Introduction to Online Puzzles. There are 3 purposes for this presentation: to outline computational thinking concepts, powerful ideas, and critical thinking strategies to incorporate into the lesson, to model the pedagogical strategies for implementing the lesson, and then at the end, we'll review all of these constructs. The 3 lessons that we're asking you to do for Course D include Lesson 3, Online Puzzles, Lesson 5, Debugging with Laurel, and my all-time favorite, Lesson 8, Dance Party. We carefully chose those 3 lessons for skill engagement and coverage of the objectives. Computational thinking strategies include loops, decomposition, algorithms, and debugging. Critical thinking strategies we'll be using include observation, predicting, planning, problem solving, looking at cause and effect, and comparing and contrasting. And we'll also be using pedagogical strategies, for example, student-centered learning, direct instruction, the PRIM approach, and how to solve problems. I'm going to show you now how to access your course, and then I'll show you I'll demonstrate some lesson planning for that. So to access your course, you can see that I am already logged in. I am going to go to Course D. So if this were you and you were logged in, you would just go to View Course in Course D. And if you don't know how to set that up, or if you don't have that set up yet, please see our previous video. And I'm actually going to demonstrate Lesson 3. You can see that I am logged in. I'm actually going to log out in order to demonstrate this for you a little better. I'm going to go to Teach. Now know that when I'm logged out, there's going to be things that I can't access, like lesson plans, but for our purposes today, it works better that I'm logged out. So I am going to demonstrate Lesson 3. Lesson 3 starts with a video. I'm not going to actually show you this video, but it does demonstrate some constructs, so definitely watch it with your students. But I'm going to start directly on Lesson 2. Now, Lesson 2, what you want to do is allow students time to play with this. It's important to give the students time to play, to think, to code without direct instruction. This is student-centered learning. So allow them to play with it. What we're hoping that what they learn is that these blocks can move. These blocks can click together. We want them to learn that these blocks can be pulled apart. Demonstrate the vocabulary. Here is our workspace. Here is our tool space. Here is our play space. I can take these blocks from the workspace and I can throw them away. I can put them back into the tool space. I can pull them out of the tool space. I can connect them. Let's see what happens if I try to run this. Just encourage them to play with the buttons. Nothing happens. There's a bug. This is not working. I can reset it. It's okay to do it wrong. We want them to get really comfortable with playing with these. And for you too, it's important that you take time to play with these programs. I can take the bird step by step, but he's not going. So let's click these together. I can hit run. And as you can see, Angry Bird successfully gets to the pig. What we don't want kids doing is just going continue, 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 and going through these programs really quickly without really interpreting what they did that led to their success. So we can ask them, what interesting things did you discover while playing with the code in the workspace in the toolbox? Answers might include the blocks click together. I can move the blocks. I can add blocks. I can get rid of blocks. What happened when you pressed run without doing anything else? Did Angry Bird get to the pig? What did you have to do to help Angry Bird get to the pig? What was your final algorithm? Here we're reinforcing the vocabulary. This is their algorithm right here. Run, move forward, move forward. Compare and contrast. What is the same and what is different between pressing run and step? What we're really doing here, the goal isn't to get the bird to the pig, that's fairly simple. What we're really doing in these first sections is getting students familiar with using the different buttons. What happens when I hit step? How is that the same? I don't want to continue. I want to keep playing in the same area. I can have the students look at the algorithm. This is the program that they wrote. What is the difference between a program and an algorithm again? Is this a program, an algorithm, or is it both? Let's look at the code button up here. Move forward, move forward. How is the code the same or different from the blocks that I'm using? Did anybody use the light bulb function? What happened when you clicked the light bulb function? Describe if that was helpful for you. We also want students to be able to understand the problem, devise a solution, transform the solution into programming language for execution. So what does that look like when we do that? That's called the PRIM approach. We want to predict, we want to run, we want to investigate, modify, make things. So while we're playing, reinforce the vocabulary. I'm going to skip ahead now. You want to let your students, you want them to play. You can see this is lesson 3. It's very similar. Let them do it on their own. Again, make a plan, predict. There's a problem here in lesson 4, isn't there? Let's hit run. Uh-oh, it didn't work. So we have a bug in our program. We need to debug it. So look at the algorithm in the workspace and compare it to the path that Angry Bird needs to take to get to pig in the play area. Remember, this is our workspace, this is our play space. Let's look at the code, the algorithm, and let's look at the path that Angry Bird has to take. So before, this is one where you can do some direct instruction. Before the students start pulling the code apart, let's let them predict. Before they even hit the play button, look at the code, look at Angry Bird, predict. What do you think will happen when I press run? Do you think Angry Bird will get to the pig? Why or why not? What does happen when we press run? Angry Bird does not get to the pig. How do we debug it? Let's come up with a plan. Let's let students come up with a plan. You can write this down. Angry Bird needs to go 1 step forward, turn left, and then go 2 steps. 1 step forward, turn left. Okay, I think this is the wrong box, but I can figure that out by using the step function. Move forward. He needs to turn left now, but look what happens. So what can we do? We can pull these apart, and I can get rid of the bad code. I can put it back together, reset it, run the lesson. Congratulations, you just debugged your program. So I'm going to skip to, we can let them play with 5 on their own, let them play with lesson 6 on their own, but we have a new construct in lesson 7. In lesson 7, you can see we have a repeat button here. Let's ask students, let's plan before we get started with this. Let's make a plan before we create our algorithm. How far forward does Angry Bird have to walk before Angry Bird turns? 1, 2, 3, 4 times. Then what happens? Angry Bird is going to turn to the right and walk 1, 2, 3, 4 more times. There are 4 ways we can do that. We can go move forward, move forward, move forward, move forward 4 times. Turn to the right maybe. Do we think that's right? And then move forward 4 times. Let's try that and see if it works. Wow, we came up with a good plan. Again, what we don't want students to do is to rush through these lessons. We do not want them just continuing and getting Angry Bird to the pig. We want them to learn how to code. So let's replay this. Look at our algorithm. Look at our computer program. What patterns do we see? 1, 2, 3, 4. Let's pull these apart and use the repeat button. Now this says 5, but I need to change that to a 4. Gonna turn right, and again, I'm gonna put a move forward, and I'm gonna change this to a 4. This is a loop. We see a repeating pattern, and when we see a repeating pattern, we create a loop using the repeat block. We can get rid of these additional pieces of code now because they're just in our way. So we are going to move them from the workspace to the tool space. Now let's see if this works or not. Fantastic. Now I'm actually going to replay this. I'm going to keep going. I'm going to ask students to show the code. Again, the idea isn't to see who can get Angry Bird to the pig fastest. The idea is to help students to understand coding constructs. Show the code. Whoa, this is a lot more involved than our previous code. You can see this means count up, stop at 4. Move forward, but stop at 4. Move forward, stop at 4. Here's our turn right. So you can almost read this code and compare it to the blocks. So to review what we went over, we used, and I'll share my screen so that you can see this better. We use computational thinking. We use powerful ideas. We talked about decomposition, debugging, loops, algorithms, program, and programming. We also use some pedagogical strategies, student-centered learning, which involves giving your students time to play, to think, and to figure out the code without direct instruction. Remember that we want to include those critical thinking strategies: predict, run, investigate, modify, and make. And this helps them to understand problem solving. And we did this by asking them questions, and the objective is not to very quickly solve the puzzle, although we do want students to be able to very quickly solve puzzles, but right now they're still learning, so we want to give them time to explore and develop their expertise. So thank you for listening, and I will see you in our next video.